We like to think of our digital world as a marvel of precision. We imagine it as a vast, clean architecture, a sprawling metropolis of silicon and logic where everything happens at the speed of light. We treat it like a natural resource, as reliable as the turning of the tides. You flip a light switch and the light comes on. You tap an icon on your phone and the information you need appears, as if summoned by magic. But there is a dark, uncomfortable secret hiding beneath the surface of the systems that run our modern lives. The banking infrastructure that handles your paycheck, the power grids that light your home, and databases that hold our collective history, these things that are not as clean or as logical as they appear. They are, quite often, held together by a fragile, terrifyingly complex web of decisions that no single human being truly understands anymore. The problem of tangled logic, spaghetti code. To understand why our digital world is increasingly plagued by mysterious bugs, sudden outages, and inexplicable slowness, we have to talk about two specific phenomena: spaghetti code and the accretion problem. Imagine a simple, elegant plate of spaghetti. When the pasta is fresh, each noodle is distinct. You can pick one up, follow it from one side of the plate to the other, and see exactly where it begins and where it ends. In the world of software development, this is what a clean code base looks like. It's modular, structured, and easy to trace. If a piece of that software breaks, you know exactly which noodle to fix. However, as you may have guessed, the reality of the software industry is rarely that neat. Development cycles are dictated by tight deadlines and intense market pressure. When a feature needs to be added yesterday, there is rarely time for an elegant architecture. Developers are often forced to take shortcuts. They reach into that plate of noodles and tie a new piece of logic to an old, unrelated function, just to get the job done, just for now. The weight of history, the accretion problem. This is the birth of spaghetti code. As more shortcuts are taken, the connections between different parts of the system become increasingly tangled. Eventually, the code reaches a state where everything is dependent on everything else. If you try to pull on one noodle, if you try to fix a minor bug in a login forum, or update a font, you inadvertently move the entire plate. A change in the user interface might suddenly crash the back-end database for no apparent reason. You've created a system where every single piece is bound to every other piece, creating a fragile, brittle mess that defies simple explanation. While spaghetti code is a description of the structure of the mess, the accretion problem is a story of how that mess grows over time. Think of a small, sturdy cabin in the woods. When it was first built, when the software was first released, it was solid, simple, and intuitive. You knew where the doors were, how the windows opened, and how the plumbing worked. It was a masterpiece of simplicity. But software is never finished. Over the years, the owners demand more. We need a balcony. We need a second floor. We need a basement. We need a garage. So, we start adding rooms. We add a shed to the side, then an extension on the roof, then a porch that hangs precariously over a cliff. We're building on top of that original foundation without stopping to ensure that the foundation can actually hold the weight. The paradox of maintenance. This leads us to the ultimate mystery. Why don't we just stop? Why don't we just tear down the Leaning Tower, delete the spaghetti, and build it properly from scratch? The answer is the most haunting part of the entire ordeal. The system cannot stop. The bank cannot go offline for a year to get a total system rebuild. The global infrastructure of our society, the systems that track our money, our identity, and our safety, are mission critical. They must remain operational 24 hours a day, 7 days a week. We are effectively trying to replace the engine of a jet while it's currently in flight, carrying hundreds of passengers. We are forced, by the nature of our interconnected society, to keep building the tower higher. We keep layering new modern technologies on top of brittle ancient foundations. We're essentially living in a high-tech society that is increasingly held together by digital duct tape and the collective prayer that the underlying structure holds for just one more day. So the next time you encounter a mysterious error or an app that suddenly stops working for no reason, don't immediately blame the person who wrote the last line of code. They are likely just the latest person tasked with balancing a new brick on top of a crumbling 30-year-old skyscraper. The mystery of modern technology is not why things break. It is how they continue to function at all. We are living in a digital house of cards, built on foundations that were never designed to hold the weight of the world we have constructed. It is a testament to the sheer ingenuity and persistence of engineers that this fragile, tangled mess continues to power our modern lives. But it is also a reminder that our reliance on these systems comes with a hidden, accumulating cost that we are only just beginning to truly understand. The real-world mystery, the Night Capital flash crash. To truly understand the consequences of spaghetti code and accretion, we don't need a hypothetical cabin. We have the story of the Night Capital Group. In August 2012, this was one of the most powerful market-making firms in the world, a giant in the high-speed trading industry. They were the invisible backbone of the New York Stock Exchange. One morning, they attempted to deploy a new piece of software. It was supposed to be a standard update. Instead, the firm suffered a total system collapse that lasted only 45 minutes but cost them $440 million, nearly their entire company. The mystery wasn't that the code failed, it was how it failed. They had accreted so many layers of old dormant code into their system that they had accidentally left behind an old unused function from years prior. When they deployed the new update, that old buried piece of spaghetti reactivated. It started firing off millions of erroneous, unwanted trades at breakneck speed. By the time the engineers realized what was happening, the damage was already done. It was the ultimate demonstration of the hidden danger. A tiny, forgotten piece of the past had reached out and destroyed the future. This is the reality of our digital age. We aren't just writing a new code, we are constantly engaging with the ghost of the code that came before. Every time a system crashes, every time a bank experiences a glitch, it is often just the echo of a decision made by someone who left the company a decade ago, whose temporary fix is still buried in the floorboards of our digital world, waiting for the wrong moment to wake up.